Concurrent lines! Concurrent lines are three or more lines that intersect at one point. While you're writing that, let me talk about the fact that we're going to be dealing with angle bisectors, medians, perpendicular bisectors, and the much less important altitudes. My whole voice inflection changed right there. Altitudes. No one cares about altitudes. So what we're really going to have is, well, three or more lines that intersect at one point. And that point is called the point of concurrency. So if I have a line and then another line and then another line, I'm trying to draw it correctly. This point right here where they meet, that point is the point of concurrency. Now you have some vocabulary. Let's keep going. Angle bisectors of a triangle. Angle bisectors are segments that cut angles in half. That's the really lame definition of it. So I'm going to just write that lame definition here. Angle bisectors, they cut angles in half. So if I bisect a 90-degree angle, half of 90 would be 45. So what I'm going to do is try, and you can just eyeball it if you want to, but I'm going to try to cut this side in half, this angle in half, this angle in half, and this angle in half. And because I'm the one giving the notes, I'm going to be as exact as I can. And therefore, I'll try my hardest to truly cut the angle in half. You can just eyeball it if you want to. But this is a 35-degree angle. Half of 35 is 17 and a half. So if you're like, well, what do? You just eyeball it. So you might say, well, this angle is this big, so I'm just going to cut it about right there. What I'm going to do is try to make mine as exact as I can. Now, I want a compass too. Okay, I'll get one. Oh, protractor actually is what that was. There we go. So what just happened was we cut this angle in half, and cutting this angle in half, and I'm using a pencil in case I make any terrible, egregious errors. Cutting this angle in half means that this angle is the same as that angle, okay? We're gonna do the same thing up here, and I'm gonna turn my paper, so it's gonna look a little weird on video, but I'll turn the paper. And we're gonna cut this angle in half as well. It looks like it's 80, so half of that would be 40. We'll just put a little dot right there, and that. There we go. That should be far enough. And here's the beautiful thing. We just talked about concurrent lines. So what we're going to do is do the angle bisector of this third one. And by the way, that means that this angle, don't mark it the same as this one, is the same as this angle. So two swooshes, they must be the same. If this is 40 degrees, which it is, then this is also 40 degrees. Okay, I'm going to cut this angle in half as well. And that angle looks to be about 68, so let's go 34. 34. All right, so I'm going to try to engineer this just right, because here's the point. Actually, for real, here's the point of concurrency. So they should meet all at one point. So if you're just kind of eyeballing it, that's totally fine. But if you're eyeballing it, they should still meet at one point. So force them to meet at one point. And that point is the point of concurrency. There we go. And so there's something really neat that's going to happen here. So first of all, let me label a few things. I'm going to label... No, I'm not. Let's not label anything. I'm going to go ahead and give you the definition of the in-center. This is the in-center, right there. The in-center is the point of concurrency of angle bisectors. That's not what I'm about to write. What I am going to write is the properties of an in-center, and it's this. All of the sides, all three sides of a triangle are equidistant from the in-center. Okay, Good to know. I'm going to stop that thought right there. We're going to write some more. Again, the incenter is the point of concurrency of an angle bisector. So I'm going to do something kind of wild and crazy with a compass. Check this out. Check this out. We'll try to get this just right. I'm trying. Ah, it slipped, it slipped, it slipped. Okay. Oops, went out just a little bit. There we go. It's going to work. It's going to work. Beautiful, isn't it? Okay, this is what I'm going to label. Man, I'm getting excited. This distance, and distance, like straight distance, least distance, is always going to be a right angle, is the same as this distance, right angle, which is the same as this one. This one's going to be just off a little bit. And if you're eyeballing it, that's fine. But all these are radii of the same circle. So we have taken the incenter of this triangle and inscribed in, prefix in, of course means, well, in, don't think too hard about that. We have put a circle inside a triangle. So here's the next sentence. Therefore, a circle can be inscribed in the triangle. Oh, let's keep going. With, no, we're in the next box. The incenter as its, well, center. All right. There we go. That takes care of angle bisectors. In the next video, we're going to deal with medians.